Okay, let's wait for a minute only, and then we will start our work, okay? And today session is going to be a little bit short from the previous one, or with respect to previous one, because I'm a little bit in hurry. So let me share the screen and then the whiteboard, okay? So you can understand things very easily. Now, okay, first, let's just start it, okay? And the first thing which we will discuss in today's session is actually about dooms, because previously it was just remained, okay? And then secondly, we will just work with arches. And then lastly, we'll just determine the quantities of different materials, okay? Just in a, you can say, straight wall, okay, with foundation. All right. And tomorrow, then we will have a small project. Okay. You can say detail estimate of a room. Okay.
مربى
Ah,
وتغلب.
okay. You have to just mute your microphone. Okay. So we don't have disturbance in our class. And I think we should skip this straight wall and foundation as well. I would like to have the rough cost estimate. Okay. Instead of that. What do you say? And we will have just an example, because there are two types of quantities, okay? You can say quantity survey, or you can say estimation. One is known by the rough cost estimate, and the other one that is known by the detail estimate. So we will discuss these both things, but in the same video, we will just focus on the rough cost estimate, because this is just straightforward and takes little bit time, okay? However, detail estimate will take much time. Now, for a detail estimate, what's important is actually three things. Okay, you must have drawings for the detail estimate. And secondly, you must have specifications. Okay, are you guys familiar with these things? And then thirdly, you must have market rates. Okay, for that, you can use, of course, MRS maybe. Okay, which is just a schedule. You can say market rate schedule or material rate schedule. Okay, it does not matter how you just abbreviate it. Okay, so I think drawing is really important, because how can you determine PCC work, maybe RCC work or plaster if you don't have drawings? Because drawings contains all the dimensions. Okay, let's say this is a wall. Okay, and let's say we need the brickwork for the same wall. Okay, now in order to determine the brickwork, we just multiply 13.5 with the volume of the same wall. So we can have the number of bricks. Okay, it is just simple. But in order to determine the volume of the wall, we need its length, then the width, and its height. Okay, and these things, okay, these three parameters can be determined, or can be, okay, just you can say noted from the drawings. Okay, that's why drawing is just important. And then we have specifications, you can say. Why is specification important? Because from the drawing, let's say if we have, you can say elevation like this one, okay? This is just elevation of a room, you can say. Now, it is known that the width of the door is 3 feet, and its height, let's say this is 7 feet. But in the drawing, it is never mentioned that what the door is made of. You can say, is it wooden door or it's aluminum door? Okay, it is never shown in the drawing. This thing can be just determined or maybe just noted from the specifications. Okay, and lastly, rates. Rate is very important for estimation, because in order to determine the cost of the building, okay, you have to determine the rate or maybe the cost of a, you can say, separate or elementary elements. You can say elements, okay, like maybe there can be different materials, cements. Okay, it's not working. Okay, cements, maybe bricks, blocks, etc., coarse aggregate, fine aggregate, okay? So you have to determine the rate of each separately, and then you have to just sum them. So you can have the cost of the total building. That's why rate is very important, okay? So let's move ahead. And if you remember previously, in the same session, we have covered something about area, and then we have covered many things about volume, okay? But one thing that is just remaining is actually about the dooms, okay? And this is a very important thing. You may have seen many dooms, okay, around your area, okay, maybe in masjids, maybe in mandars. Mandar, they may use actually something like this one, okay? Like a cone or maybe pyramid, okay? However, in masjids, okay, we may have experienced dooms like this, okay, if you have seen. And maybe in different residential buildings, maybe in other buildings, okay? So it means that we have dooms, okay, in our structures. Then how can we determine the quantity of doom? Because in order to determine the quantity of doom, what we look for is actually, let's say this is a doom, okay, and let's say this is RCC doom, okay? It means there are almost four, okay, let's say cement, and then fine aggregate, coarse aggregate, and then of course steel, okay? These four things are being used in the same doom. It means we have to determine these three materials, okay? Now in order to determine these four materials, sorry, we need the volume of the same doom, okay? It is very important. Now, you cannot determine the volume of a doom just by simple formula, okay? You have to do some, like maybe other steps, some mathematics you can say, okay? Let's just consider from the basic a ball, you can say, like this one, okay? Because doom can be half of the ball, maybe it can be segmental, okay? Segment, it can be half, okay? There are different types of the doom. Okay, now the volume of a ball, it is already just covered from the previous video. In the previous video, maybe in the class, it is actually 4 by 3 and pi r cube. Okay, now r is actually the radius from this point till that. Okay, if I just change the color, so you can see it. Okay, this is the radius. All right. Now, as you can see, if the sphere or the ball, if it's hollow, then how can we determine its volume? It's hollow. Like maybe you can say, this is solid, this one, okay? What if it is like maybe hollow? How can I represent it, okay? Maybe let's say if we have half section like this one, okay? And let's say this section, the remaining one, this is solid, okay? So this is just half section. As you can see, this is hollow. Inside, it is just, you can say empty, okay? So then we can, of course, determine the same volume. You can say we're going to subtract the internal, okay, volume, the inside volume, like this red shaded, from the external one. So it means the spare volume, if it's, you can say hollow, it must be 4 by 3, which is the same thing, okay? And then pi, and we will just subtract the inside radius, you can say r cube minus small r cube. Okay. Now, the capital R, that is actually the radius for the external, you can say surface, like that. And the small one, that is actually the radius for the internal. You can say this guy. Okay. Okay. It's simple. Any question? And further, the surface area must be, if you remember, 4 times pi r square, or maybe pi d square divided by 4. Okay. All right. Now, next, as you can see, it is very complicated to determine the quantity of a segmental doom. Like maybe we have types of doom. Let's say this is a whole circle, and let's say we have just split it into two, okay, equally. It means this is semi circular dome, you can say, okay? Semicircular. Now, what about segmental? Let's say this is uh, a sphere and segmental. Okay, semicircular, it is very important. Most of the students don't understand it. Okay, a semicircle is actually, you have to look to the chord. Okay, let's say if I have some dome like this, okay, and this is 10, it's, you can say, chord, and then the rise, let's say this is 5. How can I confirm if it's semicircular or maybe if it's segmental? Okay, as you can see, this is 5 units. It means it is twice of the diameter. So this can be radius. Okay, it's simple. It means this is just semicircular. However, if here we have another dome, let's say this guy, okay, and let's say this is 10 feet maybe or 10 meter, and let's say the rise that is just only 1 feet. It means the circle may form the same way like this, okay? The chord is not just passing the same way like this one, okay, from the center, okay? It is just maybe above the center. So it means this is just segmental, right? And we have different formulas for both. Okay, let's just consider an example, okay? So you can understand it better. Let's say we have a dome like this. We will just have an example, okay? And I think this example is very good to understand this thing better. Let's say we have a dome like this one. And it is, we you can say we are just informed that the thickness of the dome, that is just T, and let's say that is 6 inches, okay? You can have the same example in MKS system. Maybe you can say in metric system. This time I'm taking inches, no problem. All right. And then let's say it is known that the span, okay, span is actually the distance between two supports. Okay, if you remember it. And that is, let's say, 14 feet. And then we have actually the height of the same dome. Okay. And I'll take that internal. Let's say the internal height, that is 7 feet. Okay, what do you see? It means the dome is just semicircular because the rise of it is just, you can say, half of its span. It means the span can be the diameter. Okay, so we can say that is just the radius, okay, which is 7 feet. Now, if you remember, just a few seconds ago, we said a solid dome can be actually 4 by 3 pi r cubed. But this time it is, as you can see, hollow. It means we can use 4 by 3 and then pi, and we will just subtract the internal radius, you can say. Okay, you can say the capital R cube, you can say, and then minus the small r cube. Okay, to make things little bit easy. Okay, now the capital one, I'm gonna say the capital one can be, let's say this is the small one, the internal one, and for the external one, I'm gonna say this is, you can say, capital R, and that can be actually the small r, okay, plus the thickness, you can say this thickness, which is 6 inches, okay. So it means the capital R is now 7.5 feet because we have added 6 inches over there. Okay, so let's just do it. You can say the volume of the dome can be now 4 by 3, then pi. Remember, pi is just 22 by 7. Oops, what happened? 22 by 7. Okay, and then the capital R, that is just known, which is 7 by 5. Sorry, 7.5. Okay, we're gonna put that value over there, and there is remaining one thing, which is cube actually. Okay, we will subtract the internal, which is actually this thing, and that is only 7 cube. Okay, you have to do some mathematics. You can get the volume. Maybe if I use my calculator, let's say, okay, where is my mobile? Let's go here. Okay, it's almost 165 point, maybe, or 195, okay, cubic feet, because all these dimensions are in inches, maybe in feet. Okay, that's why the volume unit can be in cubic feet. Okay, it's very simple. There is nothing complicated over here. So this is how we can determine the volume of a dome which is semicircular. But the thing which is really challenging, that is actually a segmental dome. And most of the time, all the domes which I have seen, they are segmental. It means we have to learn about it. Okay, and how it works. Okay, let me just have a very simple formula, you can say, for a segmental doom. Okay, doom volume, and that is segmental. Now, let's say if we have a doom, let me just make it a little bit 3D. Okay, and let me just erase this thing. Maybe, where is it? This one. All right. Okay, if we have a doom, let's say something like this. Oops. Okay. All right. And I'm going to change the color so we can understand. Now, segmental means something like this guy. Okay. Is it clear? It is segmental now. What do you say? So it means we have to determine the volume of this thing. And this should be actually, you can say the volume must be something like pi, and there is actually h square by 3. Okay, and then you have to multiply that with 3r and then subtract h again. Now, r is actually radius of the same dome. Okay, this can be like this thing. Okay, and the radius is actually from the center to the circumference, maybe like this. So this is the radius. Now h is actually the height of the same dome. Let me change the color to red. And this is actually from this center till the top, which is the rise of the, you can say, dome. And this is h. You can say the rise. Okay. And this is simple. And pi is pi. Okay. So you have to put only these two parameters in order to have the volume of a segmental dome. Is it clear? Hello. Are you guys with me?
Yes, sir.
Okay. Any confusion? Any confusion you can ask?
सर कंफ्यूजन ये है कि इंग्लिश में लेक्चर है तो बस काफी मुश्किल आता है
अच्छा, मैं क्या करूँ, ये तो प्रॉब्लम है, क्योंकि इसमें कुछ बंदों को नहीं आती ना, फिर उनको समझ नहीं आएगी मेरी
सर
उर्दू।
कुछ के लिए हम खैर कुर्बानी दे रहे हैं
नहीं ना, वो इंटरनेशनल स्टूडेंट्स है ना, तो उनको बिल्कुल समझ नहीं आएगी। मेरे ख्याल से कुछ है इसमें, क्या कहते, बांग्लादेश के है एक दो बंदे, और वो श्रीलंका के भी है ना बंदे, तो इसी वजह से उनको फिर नहीं आएगी समझ, अगर मैं उर्दू बोलूँ। और मेरे ख्याल से मेरे ये जो इंग्लिश है ना, बड़ा सिंपल है, इसमें कोई कॉम्प्लिकेटेड वोकेबलरीज मैंने कभी इस्तेमाल नहीं की। बस ही शी वाला वो इंग्लिश है, ठीक है, तो इतना मेरे ख्याल से कंफ्यूज ना हो। अच्छा सर, इट्स ओके, वकासुल्ला, व्हाट इज ओके इंग्लिश। ऑलराइट, नाउ नेक्स्ट। So this was actually for the solid segmental. Okay, now if we have a hollow, because dooms cannot be you can say solid, because that can be a heavy structure then, and supporting that can be like maybe something like impossible. Okay, so always dooms are, you can say, constructed, okay, are modeled, you can say, hollow like this. So we will have an example so we can understand the problem. Okay, so this is segmental doom, because the curvature may go like this. Okay, and it is something whose center is just, you can say, above the center of the ball, or maybe spare like this. Okay, so this is now segmental. It means we should have different parameters now. Let's say we have the center over here. Okay, and the radius which is known, actually, let's say that is maybe I'm gonna take the internal one. Okay, let's say this one, and let's say that is 9.5. Okay, anything it can be. And now let's say the height, which is actually internal, this one, and let's say that is just only 4.5. Okay, my handwriting is very good, but because of the touch pen, it is a little bit complicated, okay, to handle these things. So just never challenge it. Now, all right, so we have these informations and we are asked to determine the volume of the same doom. Okay, this is not arch, okay, it is doom. Now, let's just calculate it. So the volume of the doom can be now, if you remember, for a solid, it was actually pi h square by 3, and then it was 3r minus h. Okay, but this time, as you can see, it is segmental as well as it is hollow. Okay, this formula is for segmental, but it was just solid, you can say. ना अच्छा ये भी प्रॉब्लम है ना क्वांटिटी में इतने ये मुश्किल चीजें इतने नहीं होती ये कभी कभार आ जाती है आप इस चीज को ना ऑटोकैड में मॉडल करके फिर ऑटोकैड में एक फंक्शनैलिटी है मास प्रॉपर्टीज की ठीक है आप उस कमांड को अप्लाई करके ना आपको मिल जाएगा इसकी जो वॉल्यूम है ठीक है इसका वॉल्यूम बड़ी इजी तरीके से इतने फार्मूले वगैरह ये कोई इस्तेमाल नहीं करते साइट पे ठीक है लेकिन मैं आप लोगों को समझा रहा हूँ ताकि आप लोगों को थोड़ा बहुत अंदाजा हो कि ये कहाँ से आता है ठीक है तो मैं क्या करूंगा अब मैं ये जो इंटरनल है ना इसको मैं सब्ट्रैक्ट करूंगा एक्सटर्नल से तो हमें ये वाला एरिया मिलेगा जो शेडेड है ब्लू में ठीक है तो सिंपल वॉल्यूम अब आ जाएगा हमारे पास लेट्स से मैं कहता हूँ कि भाई ये जो रेडियस है ना ये मैं इसको कहता हूँ कि भाई ये R2 है ये वाला हाइट R2 है ठीक है ये जो एक्सटर्नल होगा मैं इसको R1 से चलो डिनोट कर देता हूँ और इसका ये जो एक्सटर्नल रेडियस है मैं इसको सॉरी H1 को इसको H1 कर देते हैं ठीक है हाइट 1 ठीक है ये वाला भी हाइट है एक सेकंड में इसको थोड़ा हटा लूँ क्योंकि मुश्किल हो जाएगा राइट सो ये क्या बन गया भाई ये बन गया H2 ठीक है which is of course 4.5 feet and this one that is actually uh, H1 which is 5 feet okay and here we have another radius which is R1 and that is going to be 10 feet because the thickness okay this thickness T is 6 inches okay the slab it means 6 inches slab now the volume can be actually pi h square divided by 3 and then 3r minus h okay so this is for a solid and I'm gonna say let's say I'm gonna subtract the internal one from the external so let's say this is h1 this is r1 this is h1 what do you say okay we will just subtract the internal okay just in this form pi I'm gonna say h2 square right and then divide by 3 and then 3 times that is R1 but this time we can have R2 and minus H2 is it clear okay so after putting all these information in the same formula okay over here you should get 147 okay it's 45 maybe 145.56 CFT okay you have to try this and then give me the answer and you can say WhatsApp group okay if you have this answer it means you are correct if you don't get this answer it means you are wrong you are doing something wrong right so this was about dooms and now we will just switch into arches okay you may have seen arches maybe in verandas, maybe in bridges, okay, like these things. What do you say? Have you guys seen these things? So determining quantities of these arches can be a little bit challenging if you are not that good with volume calculation. Okay, and these dooms can be actually RCC dooms. These can be brickwork as well. Okay. Now, in order to determine other materials from RCC and then brickwork, maybe like you can say number of bricks, maybe cement, maybe fine aggregates or coarse aggregates. If it's RCC, you have to determine the volume of the same arch. Okay. It means knowing about arch's volume is very important for a quantity surveyor, right? Okay, so we will start from the basic, and it's actually because arch can be part of a circle. Okay, let's say we have a circle like this one. Okay, and let me take only like this position, you can say. Okay, this part. Now, this part, it is known by an arc. Okay, now if you make it 3D like this, okay, and if you consider it is a welding member, then this is just known by an arch. Okay, so these are just the same things. One is 2D, 1D, sorry, and one is just 3D. Okay, so but the mathematical calculation for both, like let's say if I need to determine the length of this arch, it is the same thing to determine the length of this arc. Okay, so it means there is nothing complicated here. Okay, now remember from the previous video, length of of a circle should be pi d, right? Or it should be 2 pi r. Okay, now if I have a center point over here and there is one radius and another radius like this, okay, radius is always same, remember. Now, if we have an angle over here, let's say that is alpha, you can also annotate that with theta, no problem. Now, if I need to determine this distance, okay, this distance should be actually this angle, okay, let's say this length should be alpha and times the radius. That's very simple, okay? But this alpha is now in radian. You can say it should be in radian. You can also convert this into degrees, okay? If you have this angle in degrees, then of course you can use pi r and alpha r and then pi and then divide that by 180. Okay, this is how you convert radians into degrees. Okay, let me just have that. Okay, if you need to convert radians into degrees, you have to multiply radians, okay, by pi by 180. It's simple. And now if you have degrees and you want to convert that into, you can say radians, you can also do that, okay? Just plug and check in or maybe rearrange these things. And I think that is 180 by pi, okay? So it means like, let's say if we have that arc and we need to determine the length of an arc, and let's say we have theta over here in radius. Now the length of this arc should be pi, you can say theta, and then r and 180. Okay, this is the length. Okay, there is another method you can just work out the length. Okay, and that is very simple. You have to just divide this theta by 360. And then if you remember, the circumference are perimeter. Okay, just multiply that. Okay, there is also another method. If you need to determine the length of an arc or maybe arch, you can just divide the theta or maybe the central angle. This is known by the central angle, okay, by 360 and then multiply that with 2 pi r. What do you say? That's very simple. Okay, so moving ahead, and we will just have an example so we can understand the problem better. Okay, now let's say if we have a maybe something like that, like something oops, where is it? Like maybe if we have a circular arch over here, okay, and let's say this is just a brick wall. Then how can we determine the quantity of brickwork for the same arch? Okay, arch can be circular as well, okay? Never be confused with that, okay? So how can we determine the quantity of this arch? If its diameter is known, let's say the diameter that is actually maybe 2 feet, okay, and the thickness of in arch, let's say that is 9 inches, okay, and let's say the wall thickness at this wall, if I can make it 3D like this and like this, the thickness of the wall that is also 9 inches, okay. So what should be the volume of the same uh, arch? It is very circular. Okay. So there can be different methods. Okay. You can determine the central, let me just change the color. If you can determine the central length like this one, and then multiply that with the cross-sectional area, so you can have the volume of the same arch. It is one method. Another method is actually if you determine this shaded area, which is area of the ring. Okay, remember from the previous video, area of the ring. Just determine this area and then multiply it with the thickness of the wall. Okay, to have the volume. Okay, so let's just work it. It's never that complex. Okay, okay. Let me just know which method should I use. Anybody? Let's try with the central line method because I know you guys are just sleeping. This is the same thing, okay? So we have to determine the center line. This is the center line, okay? And you can also use this methodology for a, क्या कहते हैं इसको, well और कुआं, जिसको हम कुआं कहते हैं, ठीक है? The thing from which we pump water, okay? Or you can say the construction from which we pump the water. So इस I mean, अच्छा, प्रॉब्लम ये मैं कभी कभी स्विच हो जाता हूँ उर्दू पे. So if I need to determine the central length, okay, this is actually also a circle which should be pi d. Okay. Now this diameter should not be 2 feet because 2 feet that is actually the internal diameter. Okay. We have to take the effective diameter which is actually up to the center line. It means half of the weight can be added to one side and half of the weight can be taken to another side. It means we have to add one weight with the diameter. So we can have effective diameter. What do you say? Okay, it is very simple. It means the effective diameter can be now 2 feet plus the weight of the, you can say, arch, and that is 0.75. And that is just 9 inches. Okay, 9 inches means 0.75 feet. Okay, so the diameter is 2.75 feet. Just put that over here, pi and times 2.75. It means we have just the same thing, the length. Okay, and let me just calculate that. If I can have 2.75, that should be L, and that should be 8.63. Okay, now we have the length. Okay, so we can determine the quantity of the same arch. Very simple. Okay, I'm gonna make some room for myself. Okay, just by removing these things. Okay, so we can calculate. Right now, the volume of the same arch should be actually the area times the length. Now, area, if you remember, the thickness of the wall that is known, which is 9 inches, and that is actually 0.75. Okay. Now, the width or maybe the breadth of the same arch that is also 9 inches. Okay. So multiply that with 0.75 again. Right. Now times the length, and that is just 8.63. Very simple. Okay. And if I'm not wrong, the volume should be 4.85 CFT. Okay, that's very simple. Any question? If there is no question, then I can move ahead, okay? to another
Sir,
problem.
sir, it how can calculate by Angwal and Shatwal method?
Okay, that topic is for tomorrow. Long short wall method, we will discuss that thing tomorrow, okay? And we will have just a small project of a room and we will just determine the complete quantity for that room. What do you say?
नो सर, ये जो आपका जो वेल का आपने जो सेंट्रल लाइन मेथड पे निकाला, तो ये लांगवाल शाटवाल मेथड पे किस तरह निकालते?
हालांकि बंदे, ये सर्कुलर चीज में लंगवाल शटवाल कहाँ से आ गया? ये तो बस सर्कुलर है। लंगवाल शटवाल तो इसमें आएगा ना। ये चलो मैं कहता हूँ कि ये लॉन्ग हो गया, ठीक है, और ये जो रिमेनिंग है ये वाला ये शॉर्ट वाल हो गया। तो लॉन्ग वाल शॉर्ट वाल ये तो लेंथ के बेस पे डिपेंड करता है ना। अब सर्कुलर चीज में तो सेंटर लाइन ही आएगा, ठीक है ना? समझ रहे हो आप?
सर तो वो शेप वाल में तो आता है ना।
नहीं, ओ शेप वाल में भी लॉन्ग वाल शॉर्ट वाल नहीं है। आप अगर ना ये चलो ओ शेप वाल है, ठीक है, इस तरह का वाल है ना ओ शेप वाल, तो इसमें लॉन्ग वाल शॉर्ट वाल किधर से आ गया? कोई लॉन्ग वाल शॉर्ट वाल नहीं है। इसको आपने सेंटर लाइन के मेथड से ही सॉल्व कर देना होगा, अगर इसके वॉल्यूम को आपने फाइंड कर देना है, ठीक है।
ठीक है सर।
अच्छा, और सेंटर लाइन,
सेंट्रल सेंट्रल लाइन मेथड तो सर इजी है, टाइम नहीं लेता है इतना। लांगवाल शाटवाल टाइम लेता
and that's why I'm saying that we will cover that tomorrow, inshallah.
है। जी सर।
Okay, we will have just a complete room estimate. Okay, there we're gonna have cross section of the walls. We will have some deduction for the windows, doors, and just consider it is a small project. Okay, that will be just very simple, right? Okay, just
ओके सर।
coming back to the arches. Okay, let's say we will have just an example of the same arch. This is not doom, okay? It is an arch. And let's say if we have the span, and let's say that span is 10 feet, okay? Then we have the rise, or maybe this guy, which is, I'm not gonna take it 5, because then the arch will be just a, you can say semi-circular arch, okay? And that is very simple, because from the previous one, let's say this one, if you just divide this video by 2, it means you are calculating the volume of semicircular arch, okay? So we will not just waste our time calculating those things. Now, this is just going to be segmental, right? And let's say this is 2 feet, okay? Any problem? All right. Now, in order to determine the length, okay, I'm gonna have the center line length for the same thing. Let's say this guy. Now, who's gonna tell me what should be the center line length for the same arch? Who's gonna tell me? Anyone?
सर इसकी थिकनेस कितनी है?
Uh, let's say if we have thickness of the same arch, that is 6 inches.
नो, थिकनेस मींस विड्थ जो हमें सामने एलिवेशन से नजर आ रही है।
अच्छा, ये वाला,
जी
ये,
जी जी।
अच्छा चलो, ये भी 6 इंचेस है।
हाँ, तो फिर ये 2.25 हो जाएगी सेंट्रल लाइन।
ये वाला, let's say this is, oops, what's going on? Okay, let's say the up to center line, you mean this is going to be 2.5.
2.25 सर।
This is going to be 2.25.
जी सर।
Yes, because that is 3 inches. You are very good.
यस
Thank you. Now next, how do you calculate its length? Because
सर,
we
सर
उसके
आर के लेंथ होती है, आर
लिए
के जो लेंथ
सेगमेंट
है।
फार्मूला।
look, there is something very, you can say, important that is just missing. Okay, if you see, the length should be pi r theta by 180. Is it okay? But this time we don't have the radius, we don't have the theta. So how can we calculate the length of the same arc? You can say arch. It is almost impossible. Okay, if we don't have these two things, the radius, okay, because the radius can be something over here. It is just segmental. So the center can be somewhere over here. Okay, this is the radius, this is the radius. And over here, we need the theta. It means, okay, never be confused with this thing. All these things should be known. Okay, you can just look at in the drawings because drawing is must. Okay, so theta must be known, the radius must be known. But I'm just challenging. Okay, I'm just confusing you. So I want you to be little bit expert with mathematics as well. Okay. Now, if you have something like this, some conditions, if you have the card, let's say this is L and let's say this is H, okay? Then of course, you're going to calculate the radius of the same curvature, okay? And you can do that if you have the radius, you can say Pythagoras theorem. This is just Pythagoras theorem. You can calculate radius by this formula. Now, it's about the theta, okay? It means we have just calculated the radius for the same formula, which is this thing. The only thing which is remaining is actually the theta. And you can also just do that by some trigonometric ratios, sine, cos, tangent, okay? Are you guys familiar with those things, sine, cos, tangent?
Yes, sir.
One is sine, okay, that is not, one is sine theta, there is cos theta, and there is tangent. Okay? And these are actually trigonometric ratios for right angle triangle. Let's say this is theta, and here we have the base. This is perpendicular, and here we have hypotenuse. So sine is actually the perpendicular by hypotenuse. You can say P by H. Okay? Cos should be actually base by the hypotenuse. B by H, and tangent should be the ratio of perpendicular by base. Okay, everybody should know about these ratios in order to be a good quantity surveyor. Okay, so if we have radius, then of course we can determine the theta, and that is very easy. Okay, as you can see, we have chord that is known, which is 10 feet. Okay, and I think I should do that in separate. Like you can say, if we have something like this, if we have chord, this is 10. Here, the height that is known, it was, if I have not forgot, that is just 2. Okay, this is 2. Okay, now the radius that is known, okay, it is something, let's say question mark. Okay, now as you can see, we have the chord. Remember, the chord should be 2r sine theta by 2. Okay, do you remember this from the land surveying? From the curves chapter. Okay, it means there is theta, and we can just calculate this theta, okay, from this point. So now we have theta, and then we have the radius. It means we can calculate the length. And then if we have length, we will just multiply that with the width and then with the height, okay, to get the volume of the same arch. Is it clear?
सर ये आर कैलकुलेट करने के लिए इसके अंदर ए की वैल्यू क्या है?
ये 2 है ना? सॉरी, ये ए जो है ना, इट्स वेरी इंपॉर्टेंट क्वेश्चन. ओके, थैंक यू वेरी मच. ओके, ए इज एक्चुअली half of the span. That is A. Okay.
Okay.
And do you guys want me to derive this formula for you? And I think it is not just related. Okay, so derivation is not that good. I can even derive this formula for you if you don't understand, or if you don't agree with the same formula, okay, the radius formula. I can derive it. It is just Pythagoras theorem. Okay.
Yes, sir.
So never be confused with it. All right, next. Okay, so this was all about arches and dooms. And now next we will just move ahead for the rough cost estimate of the building, okay? Okay, who is he? Sir, kindly use meters and centimeters, then instead of feet and inches. Okay. All right, let me just save this thing, okay? The whiteboard, so we can have another whiteboard because 20 slides are already been covered over here, okay? Is it clear?
Yes, sir.
Okay,
Yes, sir.
The rough cost estimate. We will just have an example, okay, so you guys can understand it better, okay? And the rough cost estimate that is just taken normally, okay? I'm just talking about the normal practice, okay? That is just taken based on the plant area, okay, of the building. So what you have to do is actually to determine the plant area first of the building, okay, and then multiply it with the unit rate, okay, of construction. Unit rate of construction, you can say. So this is going to be you can say the cost. However, with the same cost, we then add the cost for electricity, maybe the cost for gas supply, maybe for the water supply, okay? So this is all about the rough cost estimate, okay? And let's see how we can do it. And normally for electricity, we take the cost to 8%, okay, for the building. And then for the water supply, slash sanitary, that should also be actually maybe 4%, okay, for each. It means 8% for both. Now, for gas supply, the rough cost estimate should be, and actually this percentage, let's say 8%, this is actually 8% of the total cost, right? TC means total cost, okay? Now for the gas supply, this should be 4% of the total cost, right? It means total cost means just the cost of construction, right? And there we can have contingencies, and that should be 3% maybe, okay? And can be sometime 5%, okay? Now we will have an example so we can understand this problem better, okay? And let's say we are asked to determine the rough cost estimate. We are just asked the rough cost estimate of a building whose plant area, let's say the plant area that is known, which is maybe anything. Okay, let's say 1,000 square feet. Okay. Now, cost of the construction that is also known, which is, you can say, the unit rate that is known. And let's say the unit rate is just 1,400 RS per square feet, okay, per square feet. That's so simple. It can be different, okay, because it depends on the materials which are being used in the construction of the building or structure, okay. So this time 1,400, it is just normally taken, okay, for normal residential buildings, okay. Now, another thing which is known, actually, we are asked to determine the rough cost estimate if we have electricity supply, that is 8%. If we have water supply and sanitation, 8%. Then we have gas supply, that is, let's say 4%. And we are asked to have contingencies, let's say 3%. And contractor, you can say profit, let's say that is maybe anything can be used over here, okay? Maybe like you can say 2%, maybe 5%, okay? It depends on the size of the project, okay? So for the contractor, we have only 2%. Okay, so now how can we determine the rough cost estimate of the same building if these are the informations? Okay, so let's move ahead to the solution, or you can say calculation. In calculation, the first thing which I'm going to calculate is actually the cost of construction. It is cost of construction. And that should be the plinth area times the unit cost. You can say, which is known, and that is 1400. Okay. Now the area that is known, 1000 times 1400, that should be actually the rough cost estimate for the construction. You can say the construction cost, okay, which is just simple 1400 and in thousands. Okay, so these are the RS. Now next, we have the let me have another slide. Okay, so we can understand the problem better. So we have cost of construction, which was just calculated a few seconds ago, and that was 1400 and 000. Okay, RS. Now we will just calculate the cost for electricity. Okay, cost for electricity, and that is actually 8%. Okay, now 8%, we always just remove the percentage sign. Okay, and that's why we just divide that by 100 just to remove this thing. Okay, and times the total cost of construction, which is 1400 and 3 zeros. Okay, so you have to take 8% of the cost. Okay, and that is actually something like maybe 112000. Okay, if I'm not wrong. You can also confirm these videos, okay, little late after the class, okay, and then let me know in the WhatsApp group, okay. So we have cost of construction, one thing. Another thing is actually the cost for electricity. Now the cost for gas, okay, and that is actually 3%. 3% can be actually 0.03, okay. I'm not going to divide it by 100 because it is the same thing, okay, times the cost of construction, because it is 3% of the total cost of construction, okay. The gas supply can be 0.03 times 1400 and 000, and that should be 42,000 if I'm not wrong. Next, we have actually the contingencies, or maybe let's say water supply and sanitation. Now, water supply and sanitation, that percentage is the same for the is the, you can say, electricity, okay, which is 8%. So I can directly say 112000. This is going to be the RS for the water supply and sanitation. Okay. Now we're gonna have contingencies, but remember, before calculating the contingencies, we must add all these costs, you can say. Okay, like maybe this one plus this one plus this one plus this one. Okay, so adding all these things, let me just add them very quickly. Okay, like 112000 plus again 112000 plus that cost of construction. Okay, so we have total cost, which is actually 166, another 6, and 000 RS. Okay, another slide. I'm gonna have another slide. Now, the total cost, that is just actually now 1 point, wait a minute, it is 166 and 000 RS. Okay, now we will have contingencies. Okay, you can say 3%. So contingencies, if I'm not wrong, that spelling is actually something like this. Okay, that is 3% of this thing. Okay, 1666 and 000. Okay, so we have to take 3% of it. What do you say? It's very simple. Now contingencies are 49980. Okay, RS. So now the total cost, or you can say the grand cost, or you can say rough cost estimate, is now 1,666, 000 plus 49,900 okay, and then AD. And this is going to be actually, if I'm not wrong, this should be 17,15980 rupees. Okay, so this is the rough cost estimate for 1,000, okay, square feet length area. Anybody have any question?
सर ये परसेंट का हमें कैसे पता चलेगा कि ये चीज इतने परसेंट पे काम?
ये वैसे डिपेंड करता है प्रोजेक्ट के नेचर पे, ठीक है। कुछ प्रोजेक्ट्स ऐसे होते हैं जिसमें इलेक्ट्रिसिटी और की जो सप्लाई है ना, वो 8 से ज़्यादा भी हो सकती है, 9% भी हो सकता है, ठीक है। लेकिन ये चूंकि इस्टिमेशन है और फिर रफ का इस्टीमेट है, ये कभी भी 100% तो छोड़ो, ये 95% भी एक्यूरेट नहीं होता। इससे सिर्फ ये होता है कि आपको अंदाजा हो जाता है, ठीक है। तो नॉर्मली बेस्ड ऑन पास्ट प्रैक्टिस, अच्छा, हम इन परसेंटेज को ना यू नहीं डिसाइड करते कि भाई चलो 5% ले लो। बेस्ड ऑन पास्ट प्रैक्टिस हमने देखना होता है कि भाई चलो, आपके घर के नजदीक कोई कोई बिल्डिंग किसी ने अगर तामीर किया हो, है कोई बिल्डिंग?
यस सर।
अच्छा, तो आप उसके मालिक से पूछोगे कि भाई आपके टोटल खर्चा कितने आएगा, वो कहेगा कि भाई 20 लाख आ गया, ठीक है। फिर आप उससे पूछोगे भाई इलेक्ट्रिसिटी सप्लाई पे कितना खर्चा आएगा, वो उसने बताना होगा कि चलो 2 लाख आ गया। तो अब इस 2 लाख को आप परसेंटेज पे कन्वर्ट कर दो, आपके पास एक आइडिया हो जाएगा, कोई भी परसेंटेज आ जाएगा। तो ठीक है, इट्स ऑल अबाउट आइडिया इन पास्ट एक्सपीरियंस, ओके। तो ये परसेंटेज कभी स्टैटिक नहीं होता, ये डायनामिक होता है। डायनामिक मीन्स ये चेंज होता रहता है। अच्छा।
लेकिन इंग्लिश में है तो इंग्लिश में काफी चीजें हमसे मिस हो रही
ये बात तो भाई,
खैर है, बाकी से सर।
ये नहीं हो सकता क्योंकि इसमें स्टूडेंट्स है इंटरनेशनल, ठीक है। तो मुश्किल है। आप खैर ईद के बाद एक और सेशन है हमारा, मैं आपको उसमें फ्री में इनरोल कर दूंगा, फिर वो उर्दू में होगा इंशाल्लाह, ठीक है।
सर
तो
कोई मसला नहीं है सर, इंशाल्लाह।
यस,
ओके सर, नो प्रॉब्लम।
यस, ओके, सो
सी यू टुमारो।
सी यू टुमारो, यस। थैंक यू, अल्लाह हाफिज।
यस, ओके सर, अल्लाह हाफिज।